Hello students, we were in module 5 sampling theory. Under that we have already finished two topics on small samples, correct? For small samples we have seen t distribution and chi-square distribution. Now we will see regarding large samples. Now test of significance of large samples. The sampling distribution of large samples is assumed to be normal distribution. So whenever the samples are large, then we are considering which kind of distribution? Normal distribution. The standard deviation of sampling distribution is also called as standard error. So standard deviation, that is sigma or S of a sampling distribution is also called as what? Standard error, and the reciprocal of standard error is called precision. Now let me see the problems under sampling distribution of means. So under that there are two things. One is random sampling with replacement. Another one is random sampling without replacement. Now in random sampling with replacement, see, suppose if n is the size of finite population and small n is the size of sample, then we have n power n samples. So whenever n is the size of your population and small n is the size of a sample of that population, then how many samples we will have? N power n samples we will have. Okay, and in that case mean of this frequency distribution of sample means, here x bar indicates sample means. Okay, mean of sample means is equal to mean of the population. And what about mean of variance of frequency distribution of sample means? See, this is called as variance of frequency distribution, variance, sigma square. If it is only sigma, then it is standard deviation. Now, sigma x bar square is equal to sigma square by n. This is the variance of population. So, these are the two results whenever we considering random sampling with replacement. So, whenever they ask random sampling with replacement, we need to show mean of frequency distribution of sample means is equal to population mean. This is only mu, that is population. Mu x bar is mean of sample. Okay, then here sigma x bar square, this is called as variance of sample, this is called as variance of population. And sigma x bar is also called standard error of the means. I told you earlier also, the standard deviation of the sampling distribution is also called as standard error. So when you take the square root, you will get sigma x bar, that is called as standard error of the means. Now first, random sampling without replacement. Now second one is random sampling without replacement. So for that, mu x bar is equal to mu, and another one is sigma x bar whole square is equal to n minus n by n minus 1 into sigma square by n. So you can compare this one with this. So first one is same, correct? Mean of frequency distribution of sample means is same as mean of population, but in the case of without replacement, we have variance is given by this correction term. Okay, so for without replacement, sigma x bar square is equal to n minus n divided by n minus 1 sigma square by n. So here only sigma square by n, here there is one correction term, and this correction term tends to 1 whenever the size of the population is very large. Okay, whenever the size of the population is very large, that is when n tending to infinity, we can notice when n tending to infinity, what happens? We can take out this n out, we can take out this n out, n cancels. That time you will get 1 minus n by capital N, 1 minus 1 by capital N. So when limit n tending to infinity, this becomes 0, this becomes 0, you will get 1, 1, correct? So the correction factor becomes 1 when n is very large. Now let me see the first problem, very important. A population consists of 4 numbers. First question, find the mean and standard deviation of the sampling distribution of means by considering sampling of size to with replacement. So the first problem is of with replacement. And if n, n denotes respectively the population size and sample size, sigma and sigma x bar respectively denotes population standard deviation and standard deviation of the sampling distribution of means. without replacement, then verify that sigma x bar square is equal to sigma square by n minus n by n minus 1 and mu x bar equal to mu. This we know condition, right, for without replacement, where mu x bar is the mean distribution and mu is the population mean. Now, what they have given, see, a population consists of 4 numbers. So, in a population, we have 4 numbers, xi, which are the xi 3, 7, 11, 15. Okay. Now, find the mean and standard deviation, the sampling distribution of means. Okay, by considering sampling of size 2. So, what is n now? Small n. Small n is size of the population, size of the sample we need to take 2. Oh, okay, that we will see later on. First, we will find mean of the population and variance of the population. So, to calculate mean of the population, what is the formula? Summation of this divided by number of terms. Okay, whenever we say mean mu, sum of the terms divided by number of terms. So summation of xi is this divided by how many terms are there? 4. So what is mean mu? 9. This is for population. Now what about sigma square? What is the formula for standard deviation? We know. What is the usual formula? 1 by n summation xi minus mu the whole square. So mu already we got, correct? 3 minus 9 the whole square plus 7 minus 9 the whole square, like that. So what is sigma square? 20. So what is the value sigma? Square root of 20. So we have calculated mean mu and we have calculated standard deviation of the population. Now let us consider sample of size 2, because they have given, we need to find the sample of size 2, that is small n equal to, no, not small n, sample of size equal to with the replacement. Now we need to form the samples now based on the population. So what is the size of the sample? We need to take size as 2. So which are the cases? 3, 3, 3, 7, 3, 11, 3, 15, correct? One set. Then similarly 7, 3, 7, 7, 7, 11, 7, 15. Similarly, we can see 11, 3, 11, 7, 11, 15. Then 15, 3, 15, 7, 15, 11. So we have replaced the numbers. Okay, we have taken with the replacement. So these are the numbers we will get as a sample of size 2. Okay, so these are the numbers we will get as sample of size 2. Now we need to find the mean of these samples. Okay, mean of this sample. How to calculate the mean? We know how to calculate the mean of this sample. How to take mean? Add and divide by 2. 3 plus 3 6, 6 by 2 is 3. Okay, then here 3 plus 7 10, 10 by 2 5. Then 3 plus 11, 14, 14 by 2, 7. 3 plus 15, 18, 18 by 2, 9. Similarly, do the others also. So, we will get all the sample means. So, this is the sample we have made of size 2 with the replacement. These are the samples we have made with the size 2 with the replacement. Okay. The frequency distribution of the sampling means is as follows now. So, X, these are the sample. Yes, then here the frequency we need to do. Now, which are the sample means? We got 3, 5, 7, 9, 11, 13, 15. Correct? No? So, these are the sample means. Okay. Then 3 is repeated how many times? Only one time. 5 is repeated how many times? 2 times. 7 is repeated how many times? 3 times. 9 is repeated how many times? 3 times, 4 times. Like that, you can write the frequency distribution of sampling means. Remember, we are writing the sampling means. So, first, we need to form the sample of size 2. Then calculate the mean. Okay. Then form the table. So, which are the means you write down without repetition. Then how many times that is repeated, you need to write the frequency. Now, we need to find the mean of the sample means. Okay, mean of the sample means. So, how to calculate the summation? X into F divided by sigma F. So, X into F, 3 into 1 plus 5 into 2, 7 into 3, 9 into 4, like that you make it, because it is a frequency distribution. So mean mu is given by summation x into f divided by summation m. You will get 9. Then sigma x bar square. How to do it? Sigma summation x square f divided by sigma f minus mean of the sample mu x bar square. So this is a formula for to calculate the standard deviation of the sample mean. So that gives you 10. So what we can notice, mu x bar is 9, sigma x bar is 10, correct? So mu x bar is same as the population mean. And what about sigma x bar square? See, sigma square by n. What is sigma square we got of the population? Sigma square is 20, right? 20 by, what is the sample size? This is n is sample size. So what is the sample size 2? So sigma square by n is 10. Correct? So sigma x bar square is same as sigma square by n. So we have noticed that for sampling with the replacement, this relation holds. Correct? Now let me go for without replacement now. Now we need to consider samples without replacement. So write down the samples now without replacement. So here it is. Correct? Here we are having the values. So how to write without replacement? So first take 3, then 3 comma 7, 3 comma 11, 3 comma 15, right? Then omit 3 because we are not replacing 3. Then 7 comma 11, 7 comma 15, correct? 7 comma 11, 7 comma 15. Then omit 7, then 11 comma 15. So this is without replacement. So how many are there? 3, 4, 5, 6. Now we need to find the sample means. How to take the sample means? This, add this divided by 2, add this divided by 2, add this divided. So we'll get sample means. Now sample means we got. Now how to calculate mu x bar? Okay, so add this divided by 1, 2, 3, 4, 5, 6. Or else you can make like that. I did it in the previous thing. 5, 7, 9, 11, 13. Then write the frequency 1, 1, 2, 1, 1. Then do that. You will get the same answer. Mu x bar is equal to 9. Similarly, sigma x bar whole square is 1 by 6 into, how to do? 5 minus 9 the whole square plus 7 minus 9 the whole square, 9 minus 9 the whole square, 9 minus 9 the whole square, 11 minus 9 the whole square, 13 minus 9 the whole square. You will get 20 by 3. The same thing also you can do it here also. You can do, how you can do? Here 3, correct? 9 minus 3 the whole square, like that you can make, but it should be very lengthy. So I have written like this. Okay, frequencies I have written like this. You can write the same way here also. Okay, we'll get the same answer. Now sigma x bar whole square is equal to sigma square by n, n minus n by n minus 1. So sigma square is 20 by 2, 4 minus 2. Population size is 4, correct? N is population size. What is the population size? Population is 1, 2, 3, 4. Okay, 4. And here small n is 2. So you will get 4 minus 2, 4 minus 1. So what is 20 by 3? So what we can conclude, sigma x bar whole square is same as this. This is for which kind? Without replacement. So for without replacement, this relation holds. Okay, now let me see the next problem. The weight of 1500 ball bearings are normally distributed with a mean of 635 grams and standard deviation of 1.36 grams. If 300 random sample of size 36 are drawn from this population, determine the expected mean and standard deviation. The sampling distribution means sampling is done with the replacement, without replacement. So here everything is given. How many ball bearings are there? 1500. So capital N is 1500. What is mean mu? They have given 635. What is standard deviation? 1.36. Now they have taken the samples. How many samples they have taken? N is equal to 36. Size of 36. So 36 samples they have taken. So let me start now with the replacement. For with replacement, we know mu x bar is same as mu. So what is the sample mean also? Same, 635. Then whatever standard deviation we know, sigma x bar whole square is equal to sigma square by n. So sigma x bar is equal to square root of sigma square by n. That is sigma by root. Sigma we know, root n we know. So you'll get 0.227. This is for with replacement. Now for without replacement, this is same. And what about the variance? We know the formula. Sigma is known to you, N is known to you, capital N. Capital N is also known to you. Calculate, you will get sigma x bar. Okay. Next, consider the data as in the previous problem. So the same problem data we have to take now. In the case of random sampling with the replacement, find how many samples would have their mean between this and this, and greater than this, less than this, and less than this, or more than this. So very important problem. Let me see now. We assume the population is a normal population because they have given large sample, right? 1500. So it is a large sample. So we will take which kind of distribution? Normal distribution. And in the module 3, we have seen what is normal distribution? Normal variate, we remember that equal x minus mu by sigma, right? So for means, just we have to write x bar, mu x bar, sigma x bar. This is for population. This is for samples. So z equal to x bar minus mu x bar divided by sigma x bar. Now what and all it is given? Mu x bar is 635. Sigma x bar is 0.227. Correct now? They have given. We have to take the previous thing. Correct? They have told us to do the previous. So mu x bar we know. Sigma x bar we know. What we got? 0.224. So write down that. So this is our thing, standard normal. What is asked? We need to ask the probability of this term. Now see, since it is a normal variate, we know the normal distribution graph, correct? Normal distribution graph. So what we'll do is, we'll convert this x bar in terms of z, okay? So how to do that? We know, we have seen in module 3, how we have done that. So just you need to, this is our normal variate now, okay? So just put x bar as this. You will get minus 1.06. Just put x bar of the another one here. You will get 1.06. So our actual probability asked is this. Now we are converting this x bar to normal variate, that is that. So that will become like this, minus 1.06 to 1.06. Now this is a repetition now. In the module 3, we have seen normal table, right? Do you remember normal table? And the normal table. So in the normal table, before going to normal table, first draw the graph. See, this is a bell-shaped curve, and here it starts from minus 1.06 to plus 1. So our probability lies between this region, correct? Probability lies between this region. So that means what you need to calculate. Do you remember here to here? What is this total area? 1, correct? So here half area 0.5 and here 0.5, correct? The total area is splitted into 0.5, 0.5. So here, see, we need to write 0 to 1.06 means phi of 1.06. Do you remember? And here also 0 to 1.06. This is the left hand side of the graph. It is same as this, correct? Na? Due to symmetry, this part of the area is same as this part of the area. Do you agree? So what we can write? 2 times phi of 1.06. Now how to get this phi of 1.06? Go to the normal table. I have already given you normal table. In that go column wise 1, then go row wise 0.6. You will get this value 0.3554. Okay. Then multiply with the 2, you will get 0.7108. Next, for 300 samples, they have given it for how many samples? They have given it for 300 random samples. So you need to multiply by 300. Okay, that gives you how many samples? 213 samples. Similarly, go to the next problem. Probability x bar greater than, same thing. X bar we need to convert in terms of z. So put 635 point in the normal variate, you will get 2.203. So we have converted x bar into z. So greater than 2.203 means full, this area is 0.5. We don't want full area. We need only this part of area. So 0.5 minus this we deduct. We want to deduct this area, right? That is 0, phi of here 0 to 2.203 means what? Phi of 2.203. That is 0.5 minus phi of 2.203. So 2.20 you can get from the normal table. Value is this. Okay, value is this. Then multiply by 300, you will get 4 samples. Then next x bar less than. Similarly, go to this. And here it is, see, Z is less than minus 3.1. Now Z is less than means here, right? This way. But this is same as calculating this part, correct? Because of the symmetry, this part of the area is same as this part of the area. So how to get this part of the area? As I told you, total area is 0.5. 0.5 minus, we don't want this area. That is, we need to deduct 5 of 3.52. That gives you this value. Now last one was less than 634.5 grams or more than this. Or means you need to put plus. Okay, whenever it is or given plus. So same thing you need to do. X bar you convert in terms of Z. X bar you convert. So 634.5. Put it in the standard normal variate. Okay, then you convert it to Z. You will get, see, Z less than minus 2. Less than means same as what this side, right? That is 0.5 minus 2.2. Plus greater than means this side, correct? Greater, same thing. 0.5 minus this, we don't want the area. So 0.5 minus 5 of 1.06. 0.5 plus 0.5, 1 minus 5 of 2.2 minus 5 of 1.06. This can be got from the table. You will get the answer. Then since it is a 300 samples, you need to multiply by 300. So these are the problems under large samples. Study well. Thank you.